Hello everyone, it's March 15th. My cat just kept biting. Like a little puppy. I don't know. Like he's like teething or whatever.
He's hungry.
He's hangry, but there are still 16 minutes left before his meal time. I think he's using biting to send us a signal. But we will ignore it. We will. Alright, let's see. What do we have today? Minimum time to repair cars. Oh, another solved problem. You are given an integer array ranks representing the ranks of some mechanics. Ranks I is the rank of the ith mechanic. A mechanic with a rank R can repair n cars in r times n squared minutes. You're also given integer cars representing the total number of cars waiting in the garage to be repaired to the minimum time taken to repair all the cars. All the mechanics can repair the car simultaneously. Alright, so this is, I think it's a continuation of binary search. Wait, what is n? Can repair n cars in, okay, repair n cars in r, as r is like a multiplier, times n squared. Alright, so we have 10 cars having these ranks, so we want a minimum time taken to repair all the cars. But hold a second. Ah, yes. So you set a time, right? And then you do the time divided by the rank, and then you do a square root, and take the integer of that, and you add them up to see if it's larger or equal to cars, then you reduce the time, otherwise you increase the time. Alright, so the only thing we don't know is how to do sqrt in C++. My guess is just std sqrt. Oh yeah, and this is what we learned yesterday. The C++ does have a built-in function to find the max element in an array. I did not know that.
It's new?
It's added in C++ 17. So yes, it's pretty new. Because when we were learning C++, it was C++ 11, so it doesn't have. We're old. We're old school. Alright, C++ sqrt. Pretty much it's just sqrt, I'm pretty sure. It's, yeah, sure. It's starting from C90, 1990 version already have this function. Alright, just sqrt. Alright, let's code this very fast. I always like binary search problem because it's very the problem itself usually has a clear signal that it is binary search. In addition, it also has a very clear solution. You can, and once you understand how it works, you just go ahead and then do it. All right, why the answer is long. What are we returning? The minimum time. Ooh, holy crap, long. But card is int. Huh. That's all right. So we have to go long. Low equal to, what's the lower bound? Well, lower bound is, because you have to fix all the cars, all right? I guess the lower bound is 1. What's the upper bound? Upper bound. Well, the maximum, the lower rank is 1, right? So if the lower rank is 1, and you have everybody repair once, I think we probably have to calculate the upper bound. Cars is 10 to the 6. Is 10 to the 6 the upper bound? Well, 10 to the 6, right? That's the maximum cars. And the lowest rank will be 1. So it's 1 and we have one person doing all the cars. Then it's going to be 10 to the 6 squared. So it's the 10 to the 12th. Holy crap. 10 to the 12th. That's the maximum time. 10 to the 12th. Can long even hold 10 to the 12th? I think it can because int can hold 10 to the 9th. So yeah, long can hold 10 to the 12th. Alright. So low is 1, high is 10 to the 12th. It probably doesn't allow you, right? Because it's long. Oh, it does allow. Alright, let's do 10 to 12 plus 1. Alright, then we say while low smaller than high, long mid is low plus high minus low divided by 2. And then we're gonna go through each rank and we say count equals 0 for int rank of ranks. And what we're gonna do is, because we say mid minutes, so it will be mid divided by r, right? And then we do sqrt. So the question is, if I do divided by r, let's do instead of doing long, let's do float. Let's float here. Yeah, we don't have to float. Let's double here. Okay, double here, and we'll divide it by 2.0, right? And then this will be a double, which is fine. And then we say std sqrt, right? And then this is the end, and we take the integer of this. Okay, then we do count plus equal to this, and at the end, if count is larger or equal to cos, then we can make it even smaller. Then we say high equal to mid, otherwise we say low equal to mid plus 1. But mid is double. Damn it. That is not right. Okay, so I cannot do that. So we still do long. It's fine. And then he's here. So we get a double here. We set it to double. Security. So I just want to lose precision at the int stage, right? And then at the end, right, it will be counted small, so it will be a low plus equal 1. So I think we just return low. Shall suffice. Alright, let's take a look, see if this one works as expected. This is 225.94. Right. Binary search again. Binary search strike again. Let's check it. Alright, let's see if it is right. Not enough. Oh, dude, I think you got it wrong. It should be 100. Yep, so 10 to the 6, 10 to the 12th times 100. 10 to the 14th. Damn. That was an oversight. Absolutely an oversight. I mean, previous, it was right, 2023. My bad. I set the upper bound wrong, and we freaking overflowed. Are you kidding me? Huh. All right. Screw you. Maybe we can also be a smarter. We say if count, right? We can say if count is larger than equal to cos, then we break. How about that? Maybe you can save a few seconds on this one. All right, let's try it. Yup, that looks pretty nice. Optimized. And all right, let's check the editorial. Blah blah blah. It's going to be binary search on time. And well, look how fancy it is. So we have rank, we have minimum, maximum rank, low, high. Yeah, it's no high. This is different. It should be using the highest rank. I don't know why they use lowest rank. Space optimized. Wait. Space optimized. I do see a frequency. What the hell is this? Oh, frequency array to count mechanics with each rank. You don't have to do that. Why you just start with rank 0? I don't understand. Enjoy. Using heap. Well, just binary search this thing. All right, that's it. We're good. Let's upvote this problem. So I want to redo this one. Zero array transformation. What this is you're given integer nums. Yes. I remember. This is going to be a line sweep, right? It's a line sweep because each query we have left, right, and value. So in a decrement value at each index in this range by value at most this value, at least this value, no, at most this value. And we want to see if we can reach 0, which is what we want is go through everything, right? Go through everything and simply check at this position, do we have enough? So I think, do we sort it? Well, I do believe we keep moving forward, right? Line sweep, and I have a delta, right? I have a delta array. Okay, I have a delta array, which means in this position, this is a plus or this is a minus. So as we go through the nums array at each position, right, we will go through queries one by one, and each one will update the delta. And we are going to see if it depends, right? It depends. Now, if it's something happen in the future, then we will update the delta in the future. If the delta is happening in the past, yeah, so basically as we go through nums array, we guarantee everything on the left has already been checked and they have cleared, right? Therefore, if the current range, the start is to the left of the current index, then we don't care. We just do the delta for the current index. And if in the future, we do the future. And then we also need to do the end, right? We do the end. And we also have a starting value, right? We have a starting value. And so we handle all the delta. We handle all the delta until the current has hit. Until the current one has hit. Because we want to know the number of process, the first k that can make it into 0. So I just keep going, right? And if it exceeds the queries, then that's not possible. So I just keep going. And once I get out, we'll check. If it's already out, then it's impossible. If it's not, then it is possible. Then we'll set the next position, or use the previous one. I set the next position, and then I do this thing one more time. I should have a current. Lay down the sweetened head. Let's try it. I have some ideas. Night is falling. We come to journey's end. Alright, let's do this. So what I think is, first of all, I will set a current equal to 0. And I have to set a k, which is res equal to 0. And well, for any nums, okay, we go through every single one. And we'll say while res is smaller than line queries, right? And we also need a delta. Delta will equal to line nums plus 1, right? Oh, I do need I. Okay, so we're gonna enumerate it. Alright, so okay, so rest is smaller than this, and yeah, when do I stop? So rest current plus delta I, if it's smaller than n, okay, then we do queries. So the left to right val equal to queries, rest, right, and then we'll update delta. So it's a delta maximum I or this plus equal to val delta r plus 1 minus equal to val. And now we go for the next one. And next one. When it gets out, alright, I want to do another thing. N equal to len nm lenums len queries. Okay, so here it's gonna be n. Oh, should be this one. And here will be m, right? So when we get out, we say if I would say current plus equal to delta I. And if current is still n, and no, if current is still smaller than n, so like we go through everything, but current is still smaller than n, or return -1. I think you forget something here. Rest equal plus equal 1. And once we get out, we halve through everything, then we'll return rest. Ambiguous of left. That's fine. We know what left is. Alright, I wanna try. Not very sure. Do I have some? I do use this test case. Run. All right, looks okay. So say this is inspired by the editorial, right? The method is line sweep, but with only a single pass on nums, a single pass on nums and queries, without additional sorting. And the idea is that for each index in nums, we go through queries from left to right until we are able to just fill up. Right, just have sufficient value to so sufficient value to be equal, to be not smaller, right? To be not smaller than nums index. Right. During this traversal of queries, we update a diff array, right? A delta array, which indicates what the change will be at specific indices determined by the queries. As we move forward in nums, we make sure that each index can be fulfilled by queries. The first time, whenever a nums index does not work, right? If it does not work, we return -1. Otherwise, we keep traversing queries until we hit a step, right, where all the numbers can be accounted for. Not sure if it makes any sense, but the code itself should be pretty straightforward. Alright, I'm gonna try one more time. Make sure everything works, then we'll submit. And this will have a wrong answer. Okay, doesn't make any sense. Expected 6, output is 4. 1, 2, 3, 4. Well, maybe you do have to sort. Let's see if I sort it. Query. Oh, I cannot sort it. Burr, 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 burr. So that is 0 position. So I have 1 to 2. I set it up, and then move on. I give myself the 4, right? And then moving on to this position, then I'll give myself a 5. The first K queries. Oh. Okay, so the delta, yeah, let's try. Let's make sure we got it right. Alright, so we have delta. Shall be 4 of them, 0, yeah, like this. And starting with 0, and then we have first one, right? And then the rest is 0. Then we check current is 0, right? It's smaller than n is 1. I do see a problem. If we have a 0, then we basically... What if it's a 0? yeah, we just go forward. But now it's a 1. Right? So we get the first query. So left is 1. So basically 1 is plus 1. 2, 3, this is negative 1. Right? And the rest plus equal 1, so we move on to the next one. 0, 0, 4. 0, 0, 4. We get out. Ooh. Maybe this one will help. I'll compare current. And I'll do this. Let's try. Nope. Feel like it's getting even more wrong. Yeah, it is getting more wrong. You shouldn't. Okay, how about this? I don't do this, but here I say if current plus this is larger or equal to n, then we break. Right, and then when I get out, current plus equal to delta I. How about this one? We'll do the check later. Ah, it's still not right. Maybe I should do it earlier. Right, so basically at the rest, I take it out. I say I'll try it. And I'll do this. And then we say, is it good? Right, if it's already good, then we break out. How about this one? Ha, we just kind of trial and error. Nope. Still, this is not right. Output is 1. Why? How could you output a 1? Oh, maybe in this case. Alright, maybe I should get an index. Let's do k. Then it should be k plus 1. Because k is an index. So we do index plus 1. Of course, k needs to be smaller than n. All oversights. Huh. And the last one is still not right. It's the same. I kind of go back to the original. Okay, so 1 will give me this, right? K is 0, and it doesn't work, so go to K1. So basically this will be plus 4, right? And then this will be negative 3. Now current is 0. 0 plus 4 is larger or equal to n, so it break out. Right, so K is now here, right? We break out. And actually K is not. K is equal to 1. Right? K is 1 is at this position. K is at this position. I need to make K move forward. How about put current plus delta I smaller than here? Right, so first one's good, we plus 1. So, K plus 1, we move to the next one. And yeah, we do this first, and then we update delta, update everything. K plus 1 moves to the next one, and then go back up, then we'll break out. Let's see if this one works. Oh, it's getting worse. I see. I can just return K, right? Yeah, we're back to square one. We're back to square one, right? So, okay, plus equal 1 is here, and then I update K plus 1, so K now is here. Okay, 0, 1, 2. K is 2, and then current is 0, delta 0 is 4. It's larger, so current equal to 4. Okay, current will equal to plus equal to delta, right? Current equal to 4. Case 1 and no, so move on. So I now coming here, right? And K is here. Then we say current plus delta I. Is that smaller than n? Current is 4 minus 3 is 1. 1 smaller than no. So current plus equal to this, so current now become 1. Then move forward. So I now move here. Right? So I moving here. So K is still 2. K is still 2. And then this is 0. Right? So it's a 0. Current is a 1. And then 1 plus 0, it doesn't work. So I try K. So K equal to 2, so 0, 1, 2, we put 2 in. So if we put 2 in, right? So it's because 1, so basically 1, this is plus 5, right? And this is minus 5. I think it's because when you do the plus, you didn't really update it, because it's in the past. But it's fine. Yeah, delta I equals max I so I actually this position plus 5. Because I is equal to 2. And then this position also minus 5. So now basically here is 0. Now k move on. 0, 1, 2. K go to 3 now. Right? K go to 3. And this position is actually, yeah, it doesn't really work because the current is still 1. I shall keep moving forward. Oh, plus 5. I think I need a max here as well. So we say I or this. There we go. Try it. Nice. Nice. It's just the impact on the past it affects right now. I'm pretty sure it's different from what it was written. From the editorial. Oh, if right larger equal to index, it has a requirement. But of course, yeah, it does make sense now. Yeah, they do it here, but I do it here. Yeah, it makes more sense. Yeah, things make more sense this way. I mean, we can also try. We say if right is larger equal to index, now here can just be right plus 1. Yeah, because if the right is smaller, that means there's no more point considering it. Do you think it's gonna be faster? It's about the same. Oh, it is faster. 131. It is faster. $90.98. Consider the range that affects the current index of nums. All right, that's it. Good job. I'll see you guys tomorrow. Adios.